Yes, everybody, very warm welcome to the session. Yes, so today we are going to learn an important aspect. So this is going to be on the Hardy-Weinberg equilibrium. Okay, right. So as far as the Hardy-Weinberg equilibrium is considered, it is going to be the most important topic that you must learn as far as your evolution is considered. Yes, everybody, I hope that you are all ready for it, and I am visible, I am audible and all. Yes, everybody, come on guys. So let us watch on with this Hardy-Weinberg equilibrium and how this is going to influence your examination. Right. So before going into detail, I would like to introduce an offer to you. So here at Unacademy, we are offering the full year batch programmation as well. So now we have come up with some discount for the ones who have not subscribed to us at the portal. Okay, so based on this we have few interesting offers for you. Yes, you can see that whenever you are enrolling now. Yes, Colonel. So for the 12-month package it is 20% off. So you need to pay just 12,760. You can use my code Saranya Live, and remember, yeah, so this offer is very limited. Okay, so it is only 11 hours from now, so don't miss out this offer and learn with me at the maximum. Okay, so today we are going to learn about this Hardy-Weinberg equilibrium. Okay, so this Hardy-Weinberg equilibrium says something is going to be at the equilibrium. Okay, right. So what does mean by an equilibrium? Equilibrium means it is absolutely a constant. Okay, so whenever something is present at a constant, it is what is called as equilibrium. Okay, if something is going to vary, okay, so if there is going to create a variation, right? Yes, Purnima. So if it is going to create some kind of variation, yes, then you cannot call them as a constant, then it is going to lead to the evolution. Got it? Yes? Okay, fantastic. Yes, absolutely. So this is what, okay, so this is what it is going to do. Okay, so this is going to be the variation. Got it? Yes, fantastic. All right, good. So this is going to make up a very good important effect, and you have two major key terms in it. Okay, so number one, it is called as an allelic frequency. So what is going to be this allelic frequency? Allelic frequency generally shows about the genetic diversity. Okay, for example, when we are doing the problem, you will understand what is the difference between the allele and the genotype. Okay, so if it is going to be allelic, it is often representing the single letters, either A or small a, either tall or dwarf. This is what is called as allelic frequency. The same thing if it is phenotypic, how it is expressed. Okay, so that is what is going to be mentioned in the phenotypic. If it is going to be genotypic, it is going to see the different combination. Okay, based on that we have two important formulas. Okay, so the number one, it is about your P plus Q. Okay, so for which one this P plus Q rule will be applicable? Can you find out? P plus Q is equal to 1. This is allelic frequency or genotypic frequency? Come on everybody. Yes, P plus Q is equal to 1. This formula, it is applicable for allelic frequency or genomic frequency? Fantastic. It is allelic. Got it? Right. So then when you will use this formula, P squared plus 2PQ plus Q squared, this is the formula that you have to use whenever there is going to be the genotypic frequency. Okay, so whenever you are using the genotypic frequency, at that point you will be ultimately using this formula, P squared plus 2PQ plus Q squared. Okay, so P squared, it is representing the dominant trait. Okay, so 2PQ, it is going to be the heterogeneous trait, and your Q squared, it is going to represent the recessive trait. Okay, so these are all the quite common examples, and we come up with the Hardy-Weinberg assumption. Yes, the assumptions are, the assumptions are pretty important. You have 5 major assumptions. Whenever this assumption is followed, it is going to reach a constant. Whenever the assumptions are not met, okay, whenever these assumptions they are not at all met, then it is going to lead to variation. Got it? Yes, when the assumption is not met, it is leading to variation. When the assumptions are met, it is going to become a constant. Okay, so let us see what are the key assumptions. Okay, so assumption that is being made. Okay, right. So number 1, it is going to be the size. Okay, right. So under the size, it is pretty important, as I told you. Right. So under the size, it is going to be a very large size. Okay. So a very large size is what is going to come under this assumption of your Hardy-Weinberg equilibrium. So always any data set you take, for instance, you will apply whenever it is large. Okay. So whenever the data size is small, probably your guide will tell you, please bring more sample size, isn't it? So always everything is applicable whenever it is going to be pretty large. The second condition, there should be random mating. Okay, yes. So the random mating, this only gives more stability. Okay, so the opposite of random mating, it is going to be the inbreeding. Okay, if it is going to be the inbreeding, absolutely the variation will go. Imagine if at all you are going to the market, okay, so you get a variety of bananas, correct? Yes or no? So there will be this red banana, there will be your yellow colored banana, there will be this green colored banana, yes, there will be some native breeds, yes, so many varieties you get, correct? But if at all you go with inbreeding, what will happen? Inbreeding, it is going to make them much similar. Everything will be looking alike. So there won't be any variation. If variation is not there, absolutely no, it is going to be a very big trouble for us. So definitely we need to show the variation. Okay, yes. So you should not be always the same. That means you need the variation. So variation is what is making up with our Hardy-Weinberg assumption. If there is no variation, yes, that's all. Evolution will not happen, isn't it? Okay. So random mating means it is stability. If there is inbreeding, it is going to be uniform. So in inbreeding, heterozygotes will be there or not? Inbreeding, heterozygotes will be there or they will not be there in inbreeding. Yes, everybody, come on. I am audible, visible and all, right? Yes, everybody. Think and tell me. If there is an inbreeding, heterozygotes cannot be there. Yeah, it is going to be too much less. It is way less. So, your 2pq value will go much down. There won't be any heterozygotes. Because both are same, no. See, the father and the mother, they will be like lookalikes. How you expect the offspring? It will also be exactly same like that of the father and the mother. Okay, so there won't be much change. So your heterozygosity will be lost. Okay, right. So that is why you don't want to waste it. So you don't do the inbreeding for making this Hardy-Weinberg equilibrium. The next one, there should not be any mutation. There should not be the genes from the other sources. Yes, absolutely. So no immigration will take place, no selection. Then only it will be in equilibrium. Okay, right. So we will discuss these points in detail. All right. Yes. So the first one, it is going to be the mutation. Okay. So mutation means it is all the variation. Right. So and if at all you are at the Hardy-Weinberg equilibrium, there should be no mutation. Okay. If at all you have to deviate from the Hardy-Weinberg equilibrium, mutation should take place. Got it? Yes. Absolutely. The next thing, it is going to be the gene flow. Okay, right. So there is going to be the gene flow that is taking place. Okay, right. So as far as your Hardy equilibrium is considered, there should not be any gene flow. but if you are deviating, then there can be the gene flow. Okay, right. And next, there should not be any kind of non-random mating. Non-random mating is inbreeding. See, here that is a self-fertilization. Absolutely, you don't want it for the Hardyweinberg equilibrium. Next is the genetic drift. Genetic drift, it is going to include your bottleneck as well as your genetic drift, isn't it? So these two are literally a very important components. So they should not take place. Okay, yeah. So your founder effect, yes, the founder effect as well as your bottleneck effect, they should not take place. Yes, if they take place, then also there is going to be no Hardy-Weinberg equilibrium. Right. The next one is selection. So for Hardy-Weinberg, there is no selection. If it is not there, absolutely you can go up with the selection. Alright, yes, okay. So shall I just list down what are the characters for the Hardy-Weinberg equilibrium and what are the characters for variation. Okay, right. So for the Hardy-Weinberg equilibrium, the population size should be large. For the variation, the population size must be pretty small. And here there should be the random mating. This is very important. There should be a random mating. As far as the variation is considered, there will be inbreeding. Okay, so random mating means your heterozygotes will be more. Okay, here the heterozygotes will be less. That is the major point in it. Yes, and number 3, here there won't be any mutation. Yes, there won't be any selection. Right, there is no mutation, there is no selection, and there is going to be no gene flow. Okay, here everything is happening. Here mutation is happening. Here no selection is happening, and here gene flow is also happening. Okay, so this all will lead to variation. This all will lead to equilibrium. Got it? These 5 points are seriously damn important. If you know these 5 points, any question is going to become damn easy for you. Got it? Yes, 2 formulas. One formula is P plus Q is equal to 1. The second one is P squared plus Q squared plus 2PQ. That is also equal to 1. These 2 formulas and 5 points. You will do a lot of numericals, then you will get it. Okay, right. So coming to each point, number 1, it is going to be the selection. Okay, so how does the selection occurs? The selection is a very important point, and I told you that whenever it is at Hardy-Weinberg equilibrium, there should not be any selection. Okay, so for Hardy-Weinberg equilibrium, there should not be any selection. But in general, there are 3 types of selections. What are they? Number 1, it is called as directional selection. Okay, right. So in directional selection, what happens literally? One side is favored or one extreme it is going to get favored. Yes? So here what happens? One of the extreme it is going to get favored. Right? So that is what is called as a directional selection. So see these 2 lizards. This is lizard number 1. This is lizard number 2. Now compared to this 2, this has a very short tail. This has a very long tail. Okay, right. So compared to this 2, which one is scary for you? The moment you see which is really scaring you, it is with a long tail, isn't it? So if at all an animal is having a very long tail, it is really going to scare you because it looks like a snake. Right? So you get scared by this guy, isn't it? Absolutely. So this long tail, it is really scary. But short tails, they are not much. Yes? So, absolutely. Whenever the lizard can survey, whenever they have a good mimicry. Okay, so predators will come and see, oh my god, it is a long tail, it looks like a snake, it is going. So this trait is favored. So now you see this was the original mean. Okay, if I take this as 10, 20 and 30, this was the original mean at 20. But now it is taking a shift towards 25. Okay, so this movement is what is called as the directional selection. In directional selection, the mu itself is changes. Mu means it is the mean value itself it changes. Okay, so that is what is called as the directional selection. Usually we used to represent mu plus or minus sigma. Mu is the average, okay, yes, and the sigma is going to be the standard deviation. As far as directional selection is considered, your total mu itself will change. Okay, right. So the next one is called as the stabilizing selection. What are these stabilizing selection? The stabilizing selection, you don't have a change with the mu. See, the mu is going to remain the same, right? But what is going to change? Only the sigma or the standard deviation. Earlier, the standard deviation is from here to here. Can you see the light colored fellow? Yes, but now it is only here to here. So, which is changing in your mu? Which is changing in your stabilizing? Only the sigma. The mu, it is going to remain the same. Yeah, the intermediate zone is favored and your sigma will remain it is going to the different fellow. Okay, but this mu is remaining the same. So, for the moderate rates against the extremes, the short tails, for example, you see this cat. The cat has a very short tail. That means it cannot balance, okay, it cannot balance well, it cannot walk well. There is no balance for the short guy. But when this tail is too long, what happens? The tail will drag and it will fall down, correct? Yes, because it is going to drag with a long tail. So which one is favored here? It is going to be the moderate or the medium ones. That is why the middle one, it is going to be the stabilizing selection. Alright, yes. So the final selection is that it is going to be the disruptive selection. Under the disruptive selection, it is called as bimodal. Bi means two. It has the two means. Okay, so this is going to be one mean, this is going to be the other mean. If it has the two means, obviously it is going to become the disruptive selection. For example, you take these squirrels, okay, if at all the squirrel is going to contain a very short tail, okay, it is pretty good for it. Yes, it will escape from the predator. If it is having a long tail, it is good for its balance, okay, but medium is of no use, so it is not at all there. Got the point? Yes, absolutely. So before we are going to just move towards the next slide, we will just make a quick recap. Yes, everybody come on, recap with me fast. Yes, okay. So in Hardy-Weinberg equilibrium, if at all something else is going to reach the equilibrium, what are the condition? Number one, the population, it should be how should be the population? It should be a large one. The population should be large. Whenever there is going to be the variation, then only the population is going to be small. Yes, and then there should be only the random mating. Okay, yes, and we don't encourage the inbreeding. If inbreeding is there, it is going to become like a variation. Good. And the third point, we saw that there should not be any selection. But if there is going to be a variation, we saw three types of selection. Number one, it is called as directional selection. Okay, so this mu, it is going to change in the directional selection. Next, it is going to be the stabilizing selection. So mu is going to be the same, but the sigma is going to the change. And what is sigma? Sigma is the standard deviation. Mu means it is the mean. Yes. The third one, it is called as the disruptive selection. So what do you mean by disruptive selection? Here, this mu, it is going to be bimodal. Very good. Bimodal means two. Right. So this is what. So, but no selection as far as for Hardy-Weinberg equilibrium is considered. And we don't encourage any kind of mutation also. Okay, right, fine. The fifth one is there should not be any gene flow. Right, yes, very good. Yes, Kunal. Yeah, two means for the disruptive. And final one, yes, there should not be any genetic drift. Okay, so there should not be any genetic drift. So these are the conditions for your Hardy-Weinberg equilibrium. Okay, right. So coming to the genetic drift. So what are the two major type of the genetic drift? Number one, it is called as bottleneck effect. Okay, so see here, you can see a bottle there. So this bottle is filled with so many colored balls. This is going to be the parent population. If you see this parent population, yes, it is full of with so much of your colored species. So many species are being present up here. Okay, right, and whenever there is going to be a catastrophe, okay, is there a selection? Only blue will survive, only yellow will survive? No, whoever is able to survive through the catastrophe, they are going to escape and come. Okay, so such a surviving individuals, they will repopulate, under this condition, like the tsunami, so earthquake, yes, all these things are literally, very, very drastic catastrophic conditions, flood. We will not know who is going to escape and who is going to fall off, right? So these conditions, they only make up the survivors. Okay, so the survivors, they are going to repopulate. Yes, now COVID, yes, absolutely, it has become a pandemic, and so it is only deciding who can survive. Whoever take the vaccine, they can survive, right? Absolutely. So they are forest fire, all the catastrophe that is beyond our control. So they are only going to make up one. So they will repopulate and they will form up the next generation. Got it? So this is one of the example of the genetic drift. And for Hardy-Weinberg equilibrium, there should not be any genetic drift. So there should not be any bottleneck effect. There should not be any founder effect. But what is a founder effect? A small set of population, it is going to occupy a new one. Okay, so there is going to be a mother population. This mother population is only going to make up, it is going to create a new population. If you see the mother population, you can see more number of red, correct? Yes, so in the mother population you see a more number of red, but in the new population the red is very, very less. Okay, so we used to tell a story. So there is a boat. Okay, so in that boat actually there was a class which had 30 right-handed person and 5 left-handed person. Okay, and in this boat what happened? 4 left-handed and 1 right-handed person, they boarded the boat, and by mistake the boat it was forgetting the way back. Okay, so they went to an island. So this island will contain more people of the left hand, isn't it? So if this island, they are breeding up with each other, when they are repopulating, it will show more amount of left compared to the right, isn't it? So like at one stage it will become like 30 left and 5 right. Yes, it is opposite to that of the mother population. Yes, this is what is called as founder effect. You understood what is a founder effect? Everybody in the class? Yes, whenever they are repopulating, they become quite a different from that of the mother population. This is what is called as okay, this is what is called as the founder effect. Okay, so remember, as far as your Hardy-Weinberg equilibrium is considered, we don't want any founder effect, we don't want any bottleneck effect. Okay, right. The next important one is the gene flow. Gene flow means in founder they can balance each other. Absolutely, yes. So the founder population, it is going to create a new population. Okay, so this will be based on few pioneers. So who are all the pioneers? They are only going to dictate the new triads. Okay, yes, right, absolutely. Okay, they will repopulate them. Okay, got it, Kunal? Okay, so gene flow means few things are coming in, few things are going out. That is what is called as gene flow. The good example is, if you take this Caucasian population, okay, and the Afro-American population. These Afro-Americans, usually the Africans, they are more resistant. Yes, these Africans, they are more resistant to anything. Okay, right. Yes. Sure, Anjali, which one? You want this founder effect and bottleneck effect one more time? Sure, I'll explain it one more time. Don't worry. Yes. So see here, as far as the founder effect is considered, okay, right. You see that This is going to be the original population. Okay, right. So if you come up with the original population, it is what is represented like a mother population. Okay, right, fine. So now what will happen? You imagine that there is going to be 30 of right-handed person, 5 of the left-handed person. Okay, so relatively who is dominant now? It is going to be the right hand. Usually right hand persons, they are dominated. Yes, yes certainly, definitely. So right hand person, they are going to be dominated. Okay, right. Now what happens? They are going in a boat. Okay, so all the students, they were going in a boat. Okay, so like it happened that, within one boat, 4 left-handers and 1 right-hander was there. Okay, so in this boat all were like right-handers, so these boats and all were safe, but unfortunately this boat, it got lost. Okay, so it is reaching an island. Okay, so they have nothing else to survive, so they started surviving in that island. They began to breed among themselves. If they are going to repopulate, okay, I am assuming that they are reaching this density again, 35. Okay, right. So now what happens? This becomes 4 left and 1 right. So what will happen? Which will be more now? Left, it is going to become dominant. Okay, right. So why this happened? Why the left became dominant? Left became 30 and the right became just 5. Why it is opposite to that of this? This is because of the pioneer population. Okay, this pioneer population, it is having this trait of left. That is why, yeah, this is going to be more in number. Got it? Since they are pioneering, it is what is called as the founder effect. So who is the founder? All these L, they became the founder now. Got it? Yes, this is what is called as the founder effect. Earlier population, R should be dominant. But now because all of them are L almost, this L has become dominant now and R is very, very less. Got it? Yes? So now you understood how this became? Yeah, it has become reversed, no? So this is how the repopulation is going to work out with. Yes, Anjali, I hope that your doubt is done. Yes? Okay, good. So this is what about the founder effect, and I was telling about the gene flow. Okay, right, fine. So as far as the gene flow is considered, it is the movement of the gene from one population to the other population. Okay, right. I told you that once upon a time this malaria was very famous. Okay, right. And this malaria, if an African he is getting a malaria, nothing will happen. Okay, yes, good Anjali. But if at all an American is getting a malaria, that's all. Like how we are scared of this COVID these days, likewise, yes, these Americans, they were very badly affected. Europeans, they were very, Caucasians or Europeans, okay. So the Europeans, they were very badly affected, by this malaria. Okay, usually Europe is more susceptible. Even now you can see even this COVID condition also, Europe is very hit. Why? Because of the policies they adapt. So maybe the gene is very prone to much diseases. Okay, right. But what happens to these Americans? These Americans, they keep breeding with Africans. Okay, so Afro-Americans are very famous. Okay, so these Africans, they are resistant to malaria. So these Americans who are breeding with these Africans, they also got the resistance. Got it? Yes? Yeah, Indians, we are also less affected. Correct. We are like the Africans. Okay, so we are less affected. Yeah? But the European population, they are most affected. Okay, but then what they did, whenever these Europeans, they were mating up with these Afro-Americans, okay, so they developed the resistance. How come it is possible? Because of the gene flow. Got it? Yes, even now it is applicable, isn't it? You can see that this COVID threat, even though it was very much in India and Africa, it subsided soon. Yes, but still no, Europe and the US, they are fighting a lot. Yes, absolutely. Right, so this is what is called as the gene flow. The good example, it is about the malarial resistant gene. So this malarial resistant gene, it is actually very much pronounced with Africans. Okay, so Americo-Africans, so Americo-Africans, they were also resistant to it. Okay, but what happened to these Europeans? So these Europeans, they were most affected. Okay, malaria was hitting them a lot. It was most affected. So the gene flow by means of breeding between this European versus the Americo-African. Okay, so this led to a gene flow. Because of the gene flow, they gained the resistance. So it is all the genetic makeup which is telling. Got it? Yes. But as far as your Hardy-Weinberg equilibrium is considered, there should not be any gene flow. Gene flow should never be there. Got it? Yes. Okay. Then it is mutation. The good and in Hardy-Weinberg equilibrium, we don't want any kind of mutation. Right? Yes. And as far as the mutation is considered, the good example is going to be the sickle cell anemia. Correct? Yes. And if you take up your DNA, yes, DNA is converted to RNA to protein. Yeah. So the RNA, your sequence, it is going to undergo a change from GAG to GTG. Okay, so this is becoming GAG actually. GAG is nothing but your glutamate. But this is converted into glutamic acid. This is converted into valine. Okay, so valine, it is going to be non-polar. This fellow is polar. So when this charges are changing, it is going to lead to a sickle cell. Okay, right. Next is the sexual selection. So there should not be any selection. Right? Fine. I hope that this is all clear to you. So now let us have a look at few questions. Okay, so by looking at the questions, we will get a total idea of whether our understanding is right or what. Yes. Okay. So which one of the following it is going to have the least impact on the allelic frequencies in small population? Come on, everyone. In a small population. Okay. Yes, least effect. Okay. Good. Got it or what? So which is going to have the least effect? Yes, Kunal. What about others? It is random mating. Why? Because I told you that your Hardy-Weinberg equilibrium, it requires. Yes, Kunal, absolutely you are right. The correct answer is B only. Yes. See, Hardy-Weinberg equilibrium, it is for random mating. Okay, agreed. But it should be meant for the large population, isn't it? It should be for the large population. This fellow is small. So who is not applicable? Who is having the least impact? It should be random mating. Got it? If it is a small population, absolutely your inbreeding and all other stuff, it is going to make a very big impact. Okay, but absolutely not this one. Okay, so correct answer is going to be the random mating. Okay, so as I told you, few rules are very, very important. Number 1, your P plus Q is equal to 1. Number 2, your P squared plus 2PQ plus Q squared. Number 3rd, it is the inbreeding coefficient. This is literally very, very important formula. It is called as your inbreeding coefficient. Shall we see what is that inbreeding coefficient? It is given by the formula F, it is equal to 1 minus H by 2PQ. F, it is equal to 1 minus H by 2PQ. Okay, right. So what is F? F is the inbreeding coefficient. H is going to be the heterozygosity. Heterozygosity is called as H. And 2pq, it is going to be the numbers. Got it? Yes. So P, it is going to be the frequency of the allele A. Q, it is going to be the frequency of allele small a. And P squared, it is for AA. Q squared, it is for small a. 2pq, it is for your this thing. So this is the formula. P plus Q is equal to 1. This is for the allelic frequency. Okay. Yes, absolutely. And this is going to be the genotypic frequency. It is going to be your P squared plus 2pq plus Q squared. It is the genotyping. Got it? So shall we do the problems? Come on everybody. Yes. This is what we are all waiting for, isn't it? Yes. So consider a single locus with 2 alleles. Okay, they are at the Hardy-Weinberg equilibrium. If the frequency of one of the homozygous genotypes, it is going to be 0.64. What is the frequency of heterozygotes? Very good. So this is the genotype. Genotype means which formula you will use? The second one, isn't it? Yes. Come on. Frequency of heterozygotes means you have to find out the 2pq. So find out your Q or P. So P squared, how much it is? 0.64. Very good. So if P squared is 0.64, what is P? 0.8. Just square root. Right. It is yes, Ramprabha. Good. So it is going to be 0.8. So you know that P plus Q is equal to 1. So 0.8 plus Q is equal to 1. So Q should be 0.2. So what is the frequency of heterozygote? Heterozygote means 2pq. So it is 2 into 0.8 into 0.2. So it is becoming 0.32. Simply you can score 2 marks. Yes or no? Everybody agreed? Yes? Fantastic. Come on everybody, that's great. Okay, so let's see the next problem. Red hair. Okay, so this red hair, yeah, it is the recessive triad in human. In a randomly mating population in your Hardy-Weinberg equilibrium, 9% they are red haired. What is the frequency of heterozygotes? Yes, everybody, come on. Got it or not? I got comments or not coming up? Just a moment. Yes. Yes, Sandhya. Thanks a lot. Very good, everybody. Correct. Yes. So it is going to be 42. So how we got it? This is going to be 9, isn't it? Yes, 9 is going to be your Q squared. So what should be your Q? Yes. Okay. Sure, I will take it. Yeah, it is going to be 9%. No, so 9 by 100. So 0.09. So square root is going to be point. Yes, Ramprabha. Good. So square root of 0.09 is going to be 0.3. Yes. So what is P? 0.7. So what is 2pq? So it is going to be 2 into 0.3 into 0.7. So it is 42%. Got it, everybody? How we derived the answer? Yes. So 9%. So it is 9 by 100. So 9 by 100 it is going to be 0.09. So it is going to be square root. So we take 0.3. So the other one it is going to be sure, definitely Sandhya. So you have to prepare with 11 unit strategy these days. Yes, 11 units you must learn now. Okay, yes, it is not like the olden time. So now you have to learn with 11 units. So you can take away only 3 units away. Okay, so this is your unknown unit. Okay, so unknown 3 units alone you skip, but please see that you study almost 11 units. Yeah, totally 13 units are there. Yes, so I really want you to learn. You can skip only 2 units, not even 3. So earlier it was a 10 unit strategy. Yeah, so now I am asking you to move towards 11 unit strategy. So please don't skip plant physiology, please don't skip molecular biology as well as methods, okay, and developmental biology. Okay, so these things are like core and easy questions will be asked very directly. Okay, so these 4 things never skip. So any 2 units you can set aside. Okay, so if at all you are taking plant, animal you can give away. If at all you are taking animal but plant, don't give away. Okay, so any other unit you can skip. Got it? Yes, developmental biology is a very, very important unit. Yes, Kunal. Okay, so in a random sample, okay, yes, there is going to be 400 individuals. Okay, so there is going to be a random sample where 400 individuals from a population, it is there with the alleles of the triad in the Hardy-Weinberg equilibrium. So now what happens? Yes, yes, Sandhya, that is going to be better. Yes, Deb Malia. So first you read through the total syllabus of the methods. Okay, right. So and then once your syllabus is done, just type in the words. Okay, you have a good search engine, this Google Scholar and all, it is there now. Just type in, for example, if at all you are studying PCR, just type it like advanced PCR technique. Okay, so just put these 2 keywords. So advanced technique to find your protein interaction. So advanced technique to study this microscopy, advanced microscopy. Okay, you have to put the keywords like this. If you don't have much time, at least go through the images, images in the Google. No, so you just just see through the images. That will be absolutely enough. Okay, so after you prepare the complete syllabus, once the syllabus is done, you want to update yourself because methods you get more new things. For updation, you can do this. Got it? Yes. Okay. Fine. So coming back here in a random sample, yes. Yes, Sandhya, absolutely. Plant is very important. You can skip animal. In a random sample of 400 individuals from a population with an alleles of triad in your Hardy-Weinberg equilibrium, 36 individuals, they are going to be homozygous for the allele A. Okay, so how many individuals in the sample it is expected to carry at least one allele A? At least one allele, no, they need to carry. Yes? So how much should be the answer? Yes, Ram Prabha, very good. What about others? Come on, everybody. Yes, all. So nice of you all. Yes, keep trying. Good. How you will find this? Simple logic. Okay, so this is going to be 3 parts. Okay, one, yes, Debavalia, very good. One is going to be your A, other is capital A, small a, other is small a, small a. Okay, yes, correct, Debavalia. So now you know this total number is 400. You know this is going to be 36. At least one means these two. So 400 minus 36. So what is going to be this 400 minus 36? It is going to be 364. Hence that is going to be the correct answer for this question. Got it, everybody in the class? Did you get it how we really did this problem? Yes. So it is not about your understanding, but it is about the logical thinking, isn't it? So many CSIR question, if you observe closely, this type of question comes. Okay, right. So we learned 3 formulas. You remember that? One is, yes Kanal, P plus Q is 1. Next is P squared, 2PQ and Q squared. Third, we learnt one formula. How many of you remember that formula? F, it is equal to 1 minus H by 2PQ. It's time to apply that formula. The frequency of 2 alleles, P and Q, it is given as 0.3 and 0.7. After few generations of inbreeding, the heterozygote frequency, it was 0.28. So what is the inbreeding coefficient? Yes, apply it and tell me. That's all. You know the formula and you know the this thing. Just you have to apply and tell me. Yes, everybody, come on. Done? Once done, please let me know on this. Yes. Come on, how long? Yes? Done. Got it or not? Yes? No, the answer is C. See here. I'll show you. Okay. So the formula is 1 minus, okay, H divided by 2PQ. Correct? Yes. So 1 minus, what is H? H is going to be the heterozygosity frequency that is observed. Okay, observed divided by 2PQ is consumption. Observed is going to be now 0.28 divided by actual. Actual is 2 into P into Q. 2 into what is P now? Yes, Kunal, you are right. So this is going to be 0.3 into 0.7. So 21 into 2 it is 42. So it is 0.28 by 0.42. Yes. So that is nothing but 2 by 3. Isn't it? Right. Fine. So it is going to be 1 minus 2 by 3. So that is going to be, you can take 3 and this becomes 3 minus 2. So that is going to be 1 by 3. 1 by 3 is 0.33. Got it, everybody? You want me to redo this problem? I'll be happy to redo this one more time. Shall we redo this? Yes? Just a moment. Yes. Okay. I am not able to erase it. Okay, good. It is now erased. Okay. So see that? Yes. So you know that the formula for inbreeding coefficient. So inbreeding coefficient, what is the formula? It is going to be F. F is equal to 1 minus H divided by 2PQ. Okay. What is H? H is going to be the heterozygotes due to inbreeding. Okay, right. And what is 2PQ? It is going to be your heterozygote, actual one. Right. This is going to be the observed one and that is going to be the actual one. Okay. So what is going to be the H value here? It is 0.28. So 1 minus 0.28 divided by 2PQ. 2 into 0.3 into 0.7. Yes. So you can do this way also. It is going to be 4 times, isn't it? So this will become your 2 times, right? Yes, absolutely. So it becomes your 0.28 divided by 0.42, correct? Yes. So it is becoming your 2 by 3. So it is going to be 1 minus 2 by 3. So it is going to be 1 by 3, which is 0.33. Then, yes, definitely Sandhya, your exams will be announced soon. Okay, right. So CSIR is little bit determinate. So they will be announcing the exam either by June end. Okay, so maximum July, because still now it is only just April now. So maybe they will give a call for, and June or July definitely probability it is very high. Okay, yes. Okay, fantastic, good. So shall I just do one more numerical? Everybody is ready for one more? So problems are very little only. Okay, so we have to just know the formulas. 3 formulas only. P plus Q is equal to 1. P squared Q squared 2PQ. Then the third one, it is going to be your F is equal to 1 minus H by 2PQ. That's all, only 3. Now you see this, the genotypes they were observed in the population. Okay, yeah, it is going to be HH, HH and HH. So this is the number. Okay, they didn't give anything. Okay, they are asking which of the following is the correct frequency of the H allele. Okay, and what will be the expected number of this is actual. Okay, this is the actual number. They are asking what is the expected number of HH. Okay, wow, fantastic. Come on, good everybody. So try out this question. This is a typical classical question, isn't it? Yes. Come on everybody. Think and answer, no hurry. So what is the total number? $200 you are getting? Okay. So can you find out the ratio? 90 out of 200. So what should be the number? Yes, this should be like 60 by 200. This should be like 50 by 200. Yes? Very good. Yes, Dibmalia. Good. So it is going to be 0.45, 0.3, 0.25. Okay, right. So this is going to be for the this is going to be for the HH. This is both H and H. This is HH. So they are asking what is the ratio for H alone. Same like that last one we did know. So this is going to be combination of both. Okay, so it should be half, right? So if it is going to be the H alone, so this total we are going to take 0.45 plus half of 0.3. Okay, right. So that is going to make up a total of 0.6. So if this is going to be 0.6, small h should be 0.4. Okay, so it is quite direct. So now you are asked to find out. So 0.6 it is done. By that only you know here is the answer. Still the number. So total number is 70. Okay, 70 here, 72. Yes. So out of that, which is going to be your number? So it is going to be like so 0.6. It is asked about the total number, right? HH they have asked. Yes. So for calculating the HH, you have to put it into this formula P plus Q the whole squared. What is P plus Q the whole squared? It is going to be your P squared plus Q squared plus 2PQ. So you know that P value is 0.6 and this fellow is going to become 0.36. Okay. So now you have got the P squared value. Now you have to multiply it by the total number. Total number is 200. So that becomes the 72. This last step is very important. For the new ones, I will just explain one more time. Old ones, they are with me. Okay. So see here, as far as this question is considered, they have given the actual number. What they have asked? They have asked the expected number. This expected number will always be present based upon their formula P squared 2pq and q squared. Why? This is H allele, no, and it is in HH genotype. So genotype means only this is going to be the correct answer. Got it? Yes. So now first you have to find out what is going to be this frequency. What is P? Then only you can find out the answer. To find out P, you have the actual number. Okay. So once you got the actual number, you are going to find out what is the P. So for that you are going to just divide this by the total number. So 90 divided by 200, it is going to become 0.45. Then 60 divided by 200, 0.3. So this is going to be your HH. This is capital H and small h. So this only half value you can take. So 0.45 plus half of 0.3. So this is going to make up as 0.6. So H is going to be 0.6. So small h is 0.4. Now can you substitute this in this formula? P squared, 2pq and q squared. So P squared means 0.6 into 0.6. So 0.36 will be the answer. So this is for 1. So now the total in the population, it is going to be 200. So 200 into 0.36, that is equal to 72. Hence A is the answer. Now everybody understood this question? Yes. Okay. So is it easy, I guess? Right? Okay. So to recap, what are all the key things that you must know as far as your Hardy-Weinberg equilibrium is considered? Number 1, the population size should be very, very large, and there should be only the random mating. Okay, right, and there should be no selection. So under the selection only we saw the stabilizing selection, directional selection and the disruptive selection. Yes. Yes, absolutely Deval. So this is going to be the disruptive selection. Yes, absolutely. And then there should not be any gene flow, and then there should be no mutation. Yes, and then there should not be any no mutation, no gene and no genetic drift. Yes, under the genetic drift only we saw that founder effect, and then there is going to be the bottleneck effect. So these should not be observed as far as our Hardy-Weinberg equilibrium is concerned. So exactly the opposite, it is for the variation. Yes, for variation it is going to be a small population. Yes, there is inbreeding and there is no immigration also, isn't it? So there will be selection, there will be gene flow, there will be mutation, there is going to be genetic drift, then it is leading to variation. Yes, apart from that we saw two major formulas, isn't it? So we saw the two major formulas. Number 1 we saw that P plus Q is equal to 1. Number 2 we saw that P squared 2pq and then q squared. We will use this whenever they have given the word allelic frequency. Yes, and this will be given whenever there is a word genotypic frequency, and we will use this 1 minus yes, when the population is large it will not influence much. Okay, so see here, this is going to contain like 1000 people. Okay, right, among the 1000 people one fellow is going to have like 6 fingers. Okay, so it is not going to make a big influence. Okay, but if the population is just 10, among the 10 one is going to have a 6 fingers. Will it have an influence on it or not? Definitely, isn't it? So when it is a small population only, the variation will take off. Okay, yes, when it is going to be the large population, it is not going to influence much. Okay, so these are the important formulas that you have to look out for. So as far as your CSIR exam is considered, yes, seriously your examination needs much attention. Yes, so the main important thing is you must have a consistency in preparation. Okay, so it should not be like one day you are preparing for 10 hours, the next day you are just reading for 1 hour, and next day 2 hours, next day again 10 hours. This will not work. Keep a consistency in preparation. Have a small target. Okay, so like you should have something called as a daily target. you should have something like a weekly target, and then you should have something like a monthly target. Okay, so if at all you have not yet pasted the syllabus, please take a big printout, oversized printout of the syllabus, hang it in your room. Every day have a look at it and cross it and come. How much you have covered you should know. Then only it will be like a reward for you. Okay, I have learned this much, I have practiced this much, like that you will get to know about yourself. Yes. So if at all you have not yet subscribed as an Unacademy, absolutely it is high time that you have to come up with a subscription. So currently an offer is going on, guys. So we are offering a 20% off, and this offer is going to end soon in 11 hours. So you can use my code Saranya Live if you really like the way of my teaching. Alright? Okay guys, I'll see you up soon. Yes. Yes, Debamalya. Yes. Yeah, definitely. So if you have the 6 to 7 hours, yes, 6 to 7 hours is pretty good enough. No? Yes, so this is absolutely much enough time for you to prepare. Only thing, you should have a guided preparation. Yes, because self preparation is good, but it takes pretty long time. I highly recommend you to take up a course such that you will have a target and you can read fast with this. Yes, absolutely. So 6 to 7 hours is absolutely enough, because 3 hours you can attend the classes. Okay, right? 2 hours you can take the notes, right? And then another 2 hours you can take the test. Yes. So 1 hour test and 1 hour correction of the test. Absolutely 6 to 7 hours is plenty for anybody to crack the examination in another 3 or 4 months. Yes? Okay. All the very best, guys. I'll catch you up in another interesting session. Take care till we meet. Tata, bye-bye.